All right, welcome everybody to today's webinar on freight data integration and management. My name is Adam Hops. I'm with the National Operations Center of Excellence. Before we get started, a few updates on the webinar today. You will be muted throughout the webinar, so please use the chat box or the Q&A box for any questions for our presenters. And again, as mentioned previously, this is part of the data integration, sharing, and management for transportation planning and traffic operations webinar series. This is the 5th installment. Previous webinars can be accessed via the NOCO website, or I put a link to our most recent newsletter in the chat box, where the 3 or 4 of the previous ones are available in one spot there. So take a look at that if you'd like to see more, and you can always look on the NOCO YouTube channel as well to see all past webinars. Big thanks to Kelly Claver and the team at AAM for putting together this webinar series as part of the NCHRP project. Thank you to her and all of our panelists today. Again, this webinar will be recorded and made available to share with your colleagues afterwards. And yeah, and I saw in the chat box, I'll repost a few links so that everybody can access the information, as well as upcoming webinars on the NOCO calendar. So I'm going to turn it over first to Dan Sita and let him get started. And if you have any questions, please do use that webinar chat. Thanks, Dan.
Thank you very much, Adam. And thank you, team, for joining us today. We are looking forward to presenting to you on multiple topics and subjects on freight data integration and management. Just to give a quick overview, here is our schedule for today. I'll start with some panel introductions. We'll then go through the overview of the NCHRP project, and then there'll be multiple presentations looking at different subjects. I'll go ahead and just go here. My name is Dan Cedar. I served as a freight transportation plan and SME for this NCHRP initiative. However, with me is JP Batista with Geotab ITS. We'll just talk about what Geotab's product and some of the things that it does when it comes to freight planning and some of the use cases of their platform and the data that they provide. Adema Kofi Bonzi will also talk about from FP Innovations. Will also describe some of the work from the forestry department in terms of where and how data is being managed for forest reserves and things like that, which is quite different domain than most of us are used to. And then Mitra will close us out with that from S&P Global. Should describe in a very interesting subject moving forward in terms of emissions and forecasting, some of the work that S&P Global through their Transearch program is doing in the domain of freight planning. So these are the panel, but before we get into it, like we mentioned, Kelly Claver was a project manager on this NCHRP study, and I'll give her the opportunity to speak more about the overall NCHRP 08119 initiative and how this fits into that whole big product. So Kelly, you want to go ahead and then talk about NCHRP study?
Sure. Thanks, Dan. Good morning, good afternoon, everyone. I'm Kelly Claver. As Dan mentioned, I was have been the principal investigator for NCHRP 08119. The project started back in September of 2019, and it's wrapping up here in a couple of weeks. It was a multi-phase project that phase 1 was a big information gathering phase where we cast a wide net across a lot of different operations and planning areas to identify areas where transportation agencies could use where there were gaps or challenges with data integration, sharing, and management. And by doing that, identifying potential products that we could develop in this research. We didn't want to duplicate any past efforts and wanted to try to fill some gaps. Phase 2 was documentation of what we had found in phase 1. We did that in a website format, which I'll share with you in just a moment. And then phase 3 was the development, testing, and deployment where applicable of products that were identified in phase 1. So again, the objectives were to uncover and share effective practices, challenges, lessons learned, emerging practices and opportunities for data sharing, integration, and management, and to develop tools, methods, and guidance to improve improve upon these to enable transportation agencies to make better operating decisions. Next slide, please. So we developed 11 standalone products. I'm not going to list them all. There are quite a few. I will mention that there will be a forthcoming comprehensive final research report that will include all of these standalone products as in the report under one cover. Each one is in its own appendix, and that report will still has to go through the TRB publication review and process, but hopefully will be available with all of these products sometime next year. Today, we're going to focus on the two products that have a freight focus. And Dan will talk about those in a minute. And as Adam mentioned, we've done 3 previous webinars that focused on, there was 2 products on shared mobility. That webinar was on November 16th. We did one on November 30th on smart work zone devices and the work zone data exchange specification. And then last week we did one on a conflation tool that we developed as part of the project. And then I also mentioned the website that we developed. You can find that at data.transportationops.org. That's it's hosted by NOCO. Next slide. Just a little bit on the website. It is a centralized searchable web-based resource library that was based on the information that we uncovered in phase 1. And you can search by data application areas. There's a little bit of information about our research products and some additional resources you can see in this pull down menu. So feel free to check that out. I think there's some pretty good information all pulled into one location, and hopefully you find that helpful. So just quickly before I hand it back over to Dan to talk about our 2 freight products, I wanted to do a couple quick poll questions just to see who's in the audience. So Adam, if you can bring up the first poll question, please. So just let us know what type of organization that you represent. So we have a feel for who is on the call and in the audience today. Adam, can we show the results? Okay, so about 38% state government, 1 person from regional or local government, about 1/3 consultants, 1 university, and a few others. Okay, thank you. And poll question number 2. And then if you could just let us know which of the following best describes your role within your organization. And we'll take a look at those results. Okay. About 65% technical data analysts, 20% researchers, 1 project lead, and a couple of program managers. So thank you for that information. And with that, I will turn it back over to Dan to talk about the 2 freight products that we developed as part of NCHRP 08119.
Oh, thank you very much, Kelly, and thank you, participants, for your poll responses. So we're going to start off with the first product, which is called a freight data decision tree. The concept behind this was find a very interactive web-based tool that will allow you to determine which data set is best suited for a particular use case. And as I saw, most of you are have a strong background in technical analysis. And so that's the question that usually comes up is, what freight data should I use to address a particular question and to answer a particular issue or to use it for a particular purpose. The challenge usually that everybody faces is there are many options, and of those options, which one works best? So this tool was, I'll call it, let's say, version 1 of something that we hope can be built upon and used by others and extended further for additional use cases and new data sets as they come online. So we started off with just 4 use cases: track volumes, track congestion, origin destination analysis, and track parking. And the way it works is, if you can see my mouse, you start off with just the 4 use cases, and anytime you click on a use case, it expands further. And as you click on each use case, it expands more and more, and then gives you the list of options of all the data sets that are available for that particular use case, and in terms of where it can, what can be done and what cannot be done. It's based on JavaScript, so it can be easily extended. It's not something that is not out of the ordinary. And it just does what it's supposed to do. And once you click on, let's say, any of these, it gives you additional information. So depending on what data set you've clicked on, it gives you additional information on in terms of the metadata of the data. Where was the data collected? How is it being collected? How often is it being collected? Who is in charge of the data? What is the spatial resolution of the data? What are some of the use cases that other DOTs are using the data for? And what are some of the things that can be used with the data in the current state? So it's a pretty neat tool for any, especially if you have any new free data users, or you have any new analysts who join your company or your firm, and that wants to understand which data to use for a particular use case. And even for us expertise, just to keep us updated on what is out there and what can be done and what is available. A link to this is available through if you go to the website that is posted on chat, you should be able to access a version of this tool. And we are hoping that we could find opportunities to continue to extend this for more and more use cases. And I know most of the Q&A, you are welcome to start sending your questions, but we will answer all the questions at the end of all the presentations. Okay. All right, the second one that we looked at was freight data interoperability. So now that you know that you have a number of data sets that are able or capable of answering a particular use case, how do I make them work together? How do I make them talk together in case I'm trying to derive or cross-check the information that I'm getting from one data set in comparison to another data set? So that was a main objective of this second tool that we're looking at. It's called the freight data interoperability tool, which was just we did some initial assessments of what it's going to take in terms of build that architecture to be able to do what I just described. It's still we haven't been able to develop like the full product to show, but we're able to kind of describe the concept, and I'll take you through the concepts of this particular tool. So when you go back and look at the literature, there are a number of things out there, right? The data processing, right? We've done a lot of work. There's a lot of work in data processing. There's a lot of work in data fusion and querying. However, when it comes to the freight domain, that challenge continues to be there. This is work that this literature is coming from previous work that was done 2014. There's work that has been done in the early 2000s. There's still that same issues that were concerned a decade ago still exist, and mainly because we have different vendors doing different things, and there really isn't a standard out there for freight data collection. And these issues will continue to exist until we're able to come together and build a standardized data querying and integration approach. So building on some previous work, we looked at this ontology was developed. The ontology breaks down data from multiple sources into 8 main types, and of those types we're able to get it, let's say for this particular use case, the four main concepts: the place, which is the geography or the location, time, vehicle classification, what kind of vehicle it is, and then the use case, what are you trying to answer, what question are you trying to answer with the data. And so if you go here, we kind of start looking at this location, right? Some initial assessments. These are some of the data sets I already shared on the previous tool. So we have geotabs, streetlights, and NRICS. And if you just queried any of these vendors or any of these data sets, you realize that the data doesn't really talk to each other there. It's reported and it's shared in different formats. And as at the time this diagram has been developed, there maybe has been changes since then, but the concept of the issue still remains the same. There is, however, a standard that is available to all of us, which is the census, right? The Census Bureau has developed a geographical based approach to data querying that we can all build on, we can all kind of tally along, and that's something we should think about, right, when developing our product as data vendors, is that can we make it easy to be able to aggregate and disaggregate data in the level that pertains to what the census has available, and makes it easy for integration. So that was what this concept was. This diagram is kind of showing the challenges at different levels depending on the data sets that you are using. So I'm not going to go into the details for each of those categories. So here's the table that summarizes, right, the differences in all the different data sets, showing that there are some data sets that you can do standard queries on, like geotab, INRIX, and Streetlight, for example. You can get almost any geography just because of the way the data is collected and disseminated. However, others like H3, HPMS, those are much more customized, right? You kind of get a raw data, you customize the queries for the location that you are looking for, and be able to kind of integrate it and get what you need at that level of disaggregation. And the same thing with start and end times, right? Some data sets are annual, some are actual date and time. The vehicle classes vary quite a bit. And I know, like I said, the vendors continue to update and upgrade their offerings to be able to facilitate integration. But then some of the issues, for example, is even the routing network. There are also differences in the routing networks. The OSM, which is on the open source OpenStreetMap, is something that we should be thinking about. I know there's Arnold and HPMS are available as well, but something that is easy, that meets the need. That's one opportunity for us to start integrating data to make it easy for us to work with. So once you get all this data integrated or in a way that makes it easy to query, one of the things you start doing is that it's just a beauty, right? You have a tool that says, I want to look at origin destination analysis for multiple data sets. And so here is just an example of how this query is supposed to be done. So I pick an origin, I pick a destination, depending on what I'm looking for, right? All data sets should technically be able to give you this response. So you hit, once you go through the filters, right, of which data sets has the parameter or the data you're looking for, your OD analysis should be pretty simple if all the data sets are aligned or are standardized, and allowing us data users to be able to work with multiple data sets and be able to answer the questions that we need for the client. So I showed you the origin destination analysis. Here is a diagram just showing how congestion analysis can also be done using multiple data sets. Safety analysis, right? You're able to select the origin destination. You should be able to select a route, and then from that route, you should be able to set a buffer and be able to identify which crashes are on that buffer or fall into that buffer. The other things that also come down, like socioeconomic analysis, right? So depending on the origin and destination, you should be able to then query places and locations to be able to pull all of this data and even combine all these data sets and the outputs and just get the output as one result that it can then be used in informing the use case that you are looking for. So these are the ideal ways that multiple data sets can be queried if we are able to standardize it and make it in a way that makes it simple for users to use. So what are the challenges? The challenges right now is just the sample collection, right? The frequency, every vendor will collect the data differently. They will aggregate it differently. They will share it differently. The data quality control, depending on who you are talking to, you are not sure what the quality of the data may be. And we know that depending on the sample size as well, it may vary based on location. There's also the file storage format, right? Some data sets are distributed. Right now, mostly you can download through APIs, but some data sets will be given to you either in a zip file, an Excel file, or in something that may not necessarily be easy to work with. And then there's also, of course, the definitions in elements, right, which you have to clarify through your data dictionary to make sure that you have the right information available to you. And of course, there's the different classification systems. We have the different commodity classification systems. We have the different vehicle classification systems. We have even different roadway classification systems that may not align depending on which state you are in. Just being careful of all those discrepancies policies and making sure everything is you understand and have an idea what you are dealing with. So based on these challenges, we've invited a panelist today. I'm going to put some of these vendors on the spot. So JP, he's a business development manager at Geotab, where strong wealth of experience working with big data sets, which Geotab is basically a company that has vendor, they sell devices that is able to collect ELD data. Well, they provide ELD devices that's able to collect the GPS data at a very granular scale. And JP serves as the business development for that Geotab ITS group. And he's also actively engaged with us and with multiple partners, not just with consultants, with DOTs, and assisting them in many ways to make value or to bring value through their ITS platform. So at this moment, I'm gonna let JP take over. But then we have one more whole question for you all. This is regarding freight data challenges. We would like you to, if you don't mind, answering these selecting. Let us know what are the challenges that you when using data. What are some of the things that you may not be struggling with when it comes to using the freight data for your particular use case. And Adam, if you don't mind, we can share the results. But you should see this poll on your screens at the moment. Okay. Great. Thanks for the responses here. Okay, so access to enough data, that's always an issue with freight, and then the data quality and the level of disaggregation. Okay, great. And feel free to have any follow-up questions in the chat. We will definitely come back and answer your questions or any concerns that you may have regarding anything we've discussed. So JP, you want to go for it?
Perfect. The screen share is asking me to have you stop sharing first, and then perfect. Let me share my screen here. And can everybody see that presentation there? It's good.
We see it. You just need to hit. Yep, looks perfect.
Awesome. Thank you so much. Okay. Yeah, Dan, thank you for the introduction. Pleasure to meet everybody on this call. Just to quickly go over what we do and as a direct result of why we're here and what we're presenting about, Geotab Inc. is a telematics and fleet management company. So essentially, what we've done for the past 20 plus years is develop a piece of technology, a black box technology that gets installed and deployed across all sorts of fleet vehicles in the market, both private and public sector. This device transmits all sorts of different data on a daily basis and is utilized by many different companies in various different ways. In the context of freight, which I'll stick to for today, there is a heavy emphasis on compliance. The FMCSA has a ELD, electronic logging device mandate, that requires trucking companies to manage all of their hours of service through their ELD device. Geotab is an approved FMCSA vendor, and therefore one of the top choices for trucking companies to leverage our hardware and software to manage hours of service in order to be essentially to operate in the US and in Canada. So we've been very fortunate to be in a position where we have a high level technology with a lot of different granularities in the data that we consume and feed back to those clients in order for us to be the chosen provider to many of the trucking fleets across the US. And it's very similar to a lot of other different companies, whether it's deliveries and door-to-door use cases, light duty, medium duty trucks, passenger vehicle, commercial passenger vehicles, multi-passenger sprinter van type vehicles, and others. So with that, I'll kind of skip here to the next slide. And again, to keep this in the context of freight, but really globally, we have over 4 million connected commercial fleet vehicles. So we have one of the largest samples of commercial vehicles globally. Largely, that 4 million is largely represented in US and Canada. With that, we collect over 25 million plus trips per day and 55 billion raw data records per day. So when it comes to data quality, data management, maintaining that data, and then I'll talk a little bit about some of the algorithms applied to some of that data to further inform users with context. All of that is part of what our company has had to do prior to surfacing a big data tool like Altitude through Geotab ITS in order to provide this value back to our end fleet clients on a daily basis. So as a result, we're very fortunate as a company that we have a very rich data lake that we can pull from and glean valuable insights and context and surface that to our users through Geotab ITS. So around the end of 2021, we opened a new line of business, Geotab ITS, that essentially is intended to support a variety of different use cases, surfacing some of this insights from our ecosystem of fleets. We're able to surface, like Dan covered in his slide, vehicle classifications. We can surface it by weight classes, HDT, MDT, LDT, as well as some others. We can do it by FHA classes 1 through 8, and some other additional ways in which we can break down gross vehicle weight rating. Trip vocation, this is a very key piece of the context that we apply to the data set. We have a algorithm that is analyzing the behavioral characteristics of these vehicles. So as this pertains to freight, you're able to better understand whether you're analyzing vehicles that represent long haul trips versus local trips versus regional. Those all interact, as you may all know, in very different ways. Whereas a long haul might be traveling through multiple states where a local or regional may not. In addition to that, we surface commercial industry. This is based on the fleets themselves and the company that's represented of those fleets. And we're able to surface the primary NAICS code. Now, as it relates to freight, another very important piece here is the origin, destination, and trip chaining. Within trip chaining, since we have a persistent ID on these fleets 24/7, on this new line of business, we're able to surface trip chaining flexibility that the user can define in order to exclude stops by various time thresholds, and in order to really get a true understanding of origin and destination, especially when it comes to long haul trips that might have multiple stops along the way. Route analytics is an additional piece to the origin destination tool that surfaces all the routes that are occurring between an OD pair, as well as some other things like stop analytics and electrification planning, which are all covered within our 4 products here on the Altitude platform. So Geotab ITS Altitude platform is both an API and a visualization tool that allows users to create custom queries that reach into that raw data and surface insights post-privacy. So the intention is to provide as much flexibility into the aggregations that you choose to have, whether that's a very granular zone, a zip, a TAS, a shapefile, maybe, to Dan's point, there's census blocks and all these other valuable zones. You can upload those through shapefiles, create custom polygons or standard geopolitical boundaries, and leverage those to run various different analysis, whether it's a stop analytics analysis or an origin destination analysis, and play with the temporal aggregations as well. So going down to very granular temporal aggregations or high level. Once you've built your query and you run that query, Geotab Altitude is going to reach into that raw data lake and surface the aggregated insights or the insights post-privacy that we require in order to maintain anonymity of our clients. So privacy is obviously very important to us, but we also understand and recognize that there is a lot of value that can be gleaned from this data, and so we make sure that we're playing both, a fine line between anonymity and value for this aggregated data. So within these tools, and I'll kind of go through this a little quick here, and Dan, let me know sort of when I hit time, but origin destination, like I said, route analytics, you have all these flexibility within stop analytics. You're able to quickly identify hotspots of freight parking locations or parking along different roadways. The roads data is really helpful to identify truck congestion, speed and travel time metrics. And then our regional travel metrics supports all sorts of VMT type analysis that can either be isolated by just HDT or multiple vehicles. And I'll show you here a quick example. Last but not least is that we recognize that data needs to be representative of total population. So what our team has done, our data science team has put a lot of emphasis on leveraging the FHWA count stations, both WIM, which is very helpful for us to differentiate HDT in WIM expansion factors, and pull together a comprehensive list of all of these different stations and the expansion factor representation of our data. This is really to support our users in being able to leverage our data, expand our data to total population. So skipping along here, just to give a couple quick examples and visualizations before I pass it back to Dan. This is our origin destination tool. This was a zone created around the Port of LA and Port of Long Beach with all of the surrounding local zip codes. As you can see here from the outcomes, you can start to get a really high level overview of all the journeys that are occurring. This particular analysis was isolated to classes 6, 7, and 8. So you can see the representation by class, the vocation. So lots of these vehicles are actually just driving locally from the port to these local areas. And then the industry breakdowns as well. So largely representative of the transportation and warehousing space. From here, you can start to surface between the OD pairs, all the routes that you're seeing occur between the O and the D. Jumping along here to the stop analytics tool, just to give a few different examples around truck parking, curbside, and corridor electrification. This is a really good example in Georgia of identifying all the places where we're seeing classes 6 through 8 truck parking events for just 1 month of data. So what you're able to see here is in some of these instances, over 1,000, almost 2,000 vehicles stopping in particular locations across Chatham County. Now you can even get more granular than this, create custom polygons. You can aggregate this by hex cells, by different zones, zips, custom files. What you're going to see as well is all the associated insights. So common trend here that you'll see is the vehicle class breakdowns, vocations, industry, fuel types, the total stop counts, the vehicle counts themselves, the duration and the idle, both stop and idle duration, as well as additional insights. Now, these are the ones that I think are very key, especially when looking at trucks. You're able to surface things like trip distance before and after the stop and trip duration before and after the stops. Now, when you're looking at different truck stops, for example, this is a really good indicator of a place that's being used for overnight stops or just as a quick stop location. And then again, this is just another layer of aggregation within the stop analytics tool, more so looking at curbside management and looking at road segments through the OSM base map. Again, same layers of context. And then the last example here that I wanted to surface was the regional travel metrics. So this is their VMT API. Now, what we're looking at here is all the heavy duty trucks by county in the state of Georgia. So what you're looking at here is all of the little dots being the expansion factors, color-coded by the largest representation of HDT by region, being the darker dots, and the lighter dots being the lower representation. So where you see light, very dark, we seem to have a very good coverage in those areas. So of course, by the ports and some of these major areas within Georgia, we're having a very great representation of our vehicles. The same here is color-coded by VMT. So again, you can start to really map out by VMT all of the local corridors driving to Florida, driving to the ports, all the major areas where there is high-level VMT by county. Again, you can start to break these things down by vocation or all of our attributes. So in this case, when you're looking at Fulton County, a majority of the VMT is generated by long-haul trucks. Very interesting metric when you couple it with things like industry and total VMT usage as well. I try to kind of, for the sake of time, burn through that quickly, but please don't hesitate to ask any questions. Myself and my colleague Jamie, who's also on the call, will be happy to answer any questions.
No, thank you, JP. As JP mentioned, if you ask questions, there are a number of questions that come up, right? From a free data management perspective, questions like How do you go about addressing locations that we don't have sufficient data from? How do you go about aggregating and understanding that you are meeting the client's expectations in terms of the data, how disaggregated data is and all of that. So feel free, if you have any questions, put it in the chat. We're going to try to answer as best as we can during this panel discussion. Okay. Right. So we've seen questions coming in already. That's great. So I'll move on to Adime. Adime is a senior researcher in the Transportation and Infrastructure Research Group at FP Innovations. He has over a decade of experience in transportation research, and his expertise is in vehicle systems testing and certification. So he obtained his Master of Engineering degree from McGill University in Montreal, Canada, and his Bachelor of Science from the University of Alabama in Huntsville. So Adime is currently leading or serving as a project lead for digital transformation at FP Innovations, and also being a lead for a number of years on their ELD data certification program. So you heard from Geotab. Geotab had to go through the certification, or to go through that validation before they could be a vendor. Approved by FMCSA, and FP Innovations through Adime Bonzi are one of the companies that goes through that does some of this certification. So Adime, based on your experience and working in the forestry department, I'm looking forward to hearing from you as well. So Adime.
Thank you very much, Dan. Just let me know if you can see my presentation.
Looks good. Yeah.
Okay. Thank you. It's a pleasure to be here to have this discussion with you. I'll be talking about transportation data management in forestry. So just as a summary, we'll talk a bit about FP Innovations and some of the work that we're doing. Look at FP Innovations' unique placement in a cross-sector industry, a few points related to value chain and data flow, and then we'll get into a discussion about some approaches for optimizing transportation efficiency and our work in digital transformation and digitalization. And I'll conclude with a few considerations to you as data experts in the industry as it relates to some of the challenges and areas to look into to help provide solutions for our industry as well. So as an introduction to FP Innovations, it's a not-for-profit private applied research center with a focus on creating solutions to support the Canadian forest sector's global competitiveness. And we do have a unique industry government partnership model which allows us to be a catalyst for Canada's forest sector. And there's also a very strong sectorial support from the federal, provincial, and territorial governments. We also have partnerships with universities and other research institutions in Canada and in other areas of the world. So this is sort of a quick introduction into providing a snapshot of where the focus is and where our funding sources are. And it kind of shows the relationships that we have with industry and government. So I'll say a majority of funding comes from federal governments and provincial governments. And then we also have membership-based funding from our members. We have some contract work that we do, and then other funding comes from initiatives and other sources. FP Innovations has over 390 employees across Canada, works in close collaboration with about 93 industrial members, and we operate on a budget of about 70 million Canadian dollars. So this map shows in green our FP Innovations offices across Canada, and then in purple our pilot plants. So I'll just point here briefly to our head office in Pointe-Claire, in the Montreal area in Quebec, Canada, which is where I work out of. And then our offices in British Columbia, Vancouver, British Columbia, and in Quebec City as well. So in terms of research and innovation, our focus has to do with delivering value to our members and to our clients. In the Fiber Supply Innovation Center of Excellence, which is the area that I'll be focusing on because that's where forest operations sits, we focus on driving research to deliver value to the industry through innovation. So our focus here again is on transportation and infrastructure for this conversation, but there are other research areas and other innovation centers of excellence that I'll not be touching on in this conversation. And why transportation? Why is a forestry research organization interested in transportation? Well, the answer is in the value chain. So if you kind of follow my my cursor here, we'll go round from upstream to downstream. So from the planting of trees all the way to the delivery of products on the market, we see that transportation forms part of this value chain in two areas. And from estimations and research that has been done, the cost of transportation is about 40%, or the cost of producing or delivering wood products has about 40% coming from transportation. And this is a pure cost, right? Transportation does not add to the value of the product. It just moves it from one place to another. So it's a pure cost. And so incentives to optimize transportation to reduce costs must be at the forefront of the work that we do. And we need to understand the interconnectivity and data flow through the value chain if we are going to be successful in making any roads leading to improved efficiency. So transportation needs can be highlighted by the following: sustainability of wood supply and transport in forest operations, also implementing data systems to meet compliance. So we saw from the previous presentation a little bit of a discussion about hours of service and electronic logging devices. Implementing technologies to support critical decision making, so that operators and forestry companies can make better decisions based on data rather than make educated guesses. Valorizing existing data using advanced analytics to identify critical issues in near real time so that they can be addressed and prevent further losses. And all these come together to maximize cumulative impact for operations. So we're looking at areas of reducing cycle time, for example, maximizing productivity, improving energy efficiency, and then minimizing operating costs. These are general needs and objectives of the forestry industry. So what are the challenges that are related to the use of data, and how can these be mitigated? First, it's not a secret that telematics and telemetry systems are widely deployed. There are several providers out there, but the data that comes from these systems is underutilized. And this is because data analysis is labor intensive and costly, and most of the people who own the data see it as an extra task or an extra step to their daily work. And so much of this data is collected but underutilized. There's a lack of required skill sets, and that could be why data analysis is so labor intensive. And then external technical support is limited in most cases. And then there are complex compliance requirements, cycle time and tracking rate analysis are also quite complex. So the industry needs solutions, and we find some of these in the digitalization process and digital transformation. So digitalizing tracking operations to generate value from existing data is an area that we are working on currently to deploy advanced data analytics for continuous and remote support in operations. And this will allow us to provide real-time support and help with more complex calculation of rates and such using real data. So optimizing transportation efficiency is a two-prong approach from our vantage point. First, the first prong deals with identifying gaps and data requirements. So where are the issues? Similar to everything that you're working on. And so I think that some of the ideas and highlighting the challenges that we are facing in our industry could help drive the approaches that you're taking as well. So identifying gaps and data requirements as related to forest transportation involves identifying specific needs of the forest trucking fleet operations. And because of our close work and collaboration with them, we are able to easily identify where these gaps are, identifying critical data parameters, and also coming up with meaningful key performance indicators. And then we can move into optimizing transport efficiency. And this has to do with providing solutions. There could be a combination of different solutions, approaches, and methods, but providing solutions for the industry based on advanced data analytics and process expertise. We have to have process experts who understand the business, who work with data analytics providers and data scientists to support the industry in this data management approach. And then finally, validate and improve and expand on the scope for broader impact. So the rest of the presentation will try to touch on some of these key areas in blue that I have mentioned. So I will not talk too much about vehicle telemetry. I think that we have a good understanding on that. But I'll just highlight real quickly here as it relates to hours of service and ELD management that there has to be interoperability between Canada and the United States. The regulations are a little different. The requirements are a little different, but at the base, the data that's collected is the same. And on the next slide, I'll discuss this. So as we look into vehicle telemetry solutions, and finding out where the gaps are, we understand that there is a complexity of operations, data sources, and data flow, and we need to come up with a framework that helps to simplify data acquisition methods, data analysis methods, and understanding where the data is going and what it can be used for. Secondly, a lot of solutions are developed for freight transportation, but forestry has some unique operational differences that need to be considered as well. And at the end of this presentation, I will be talking about that. So there is a need for forest transportation expertise in the discussion around data management. A quick layout of the ELD system communication structure. So there's a vehicle, a commercial motor vehicle. It is installed or equipped with a recorder which has an interface, and this will be what will be called the in-cab component of an ELD or telematics system. It's based on GPS data. Or it uses GPS data for positioning, and information from the vehicle, from the driver, can be sent or is required to be sent to enforcement. Information is also sent to the motor carrier, in most cases through a cloud server, and the motor carrier also sends or is required to send information to enforcement. So that's sort of the data map for ELD use based on the requirements that are provided both in Canada and in the United States. Here I'll highlight just the parameters that are required for ELD data requirements. So date, time, vehicle position, vehicle speed, vehicle power status, vehicle operational parameters. So things including the vehicle name and number, the VIN, and so on and so forth are required to be captured by these devices to ensure that it's synchronized with the ECM. It allows manual inputs, and it captures records of duty status for the driver that is using them. It's also required to generate and transfer standard output files. Now, there are different architectures, but regardless of the architecture, the functional requirements are the same for all types of architectures that are deployed. Now, beyond hours of service and ELD, we need some key performance indicators to help us to improve operations. And so we begin to look at adapting KPIs for forest transportation from the existing platforms. Some of these KPIs are not directly obtained from the reports that are available or functionalities that are available. And so current usage is mostly for safety metrics, and some limited cycle time reporting. So we need tailored KPIs that can be generated through digitalization, extracting the data to use it for further analysis to facilitate dispatching, identify inefficiencies in the supply chain, provide dynamic inputs for tracking rates, and to facilitate comparative analysis. And so these are some examples. It's not an exhaustive list, but some examples of KPIs that are being looked at in our work. So productivity, payload, energy intensity, which is based on calculations on data from different sources, not just the telematics device. Cycle times, loading times, safety metrics, etc. So these are KPIs that we can use for deeper analysis. And so an automated data analytics structure would look, something like this. One, a data acquisition, so developing a data pipeline to collect information at certain frequencies. Second, performing data analytics, so data integration and advanced computing, mostly done in the cloud. And this will spit out real-time detection and rapid recommendations to help operations, finding where the issues are, finding where the trends are, associating any issues that are identified to root causes, and providing actionable interventions. And this is the work that we're currently doing. Now, in order to develop a framework, we have to understand the complexity of the issues. So as I mentioned, we find where the gaps are, we come up with a strategy to solve the issues, but we also need to understand the complexity of the issue. So, complexity goes all the way from, incomplete data to having multiple data streams that need to be integrated. And so the expertise and the approaches will follow suit in order to be able to achieve in order to be able to solve the issues and provide solutions that make a difference and make impact in the in operations. I'll conclude with this. So as I mentioned, I would like to share a few points for consideration as you data experts and solutions providers are developing your solutions and coming up with frameworks. There are specific issues in forestry transportation that need to be looked at or addressed. In operations, we are looking at logistics and communications and connectivity. As Dan mentioned, some of these operations are in areas where there is no GPS or cellular network. And so we need solutions that can still collect data and then transmit the data once they're back on the grid. Data acquisition. So what level of granularity allows data scientists to take the data and do more with it? In many cases, we are looking at summary data instead of data that is at a certain level of granularity and frequency that allows for further analysis. KPIs for safety and training to help driver performance and behavior and improve these areas. And then business intelligence and digital transformation. So coming up with prediction models, dynamic tracking rate analysis, trend and issue identification based on historical data analysis. And finally, we see a surge of vehicles with alternative fuels, electric and hybrid powertrains, and integration of data from other forest equipment, not just trucks. And so platforms and systems that allow us to do this analysis to come up with strategies and improved KPIs to further increase efficiency in operations are considerations that we need to take as we are developing this framework. In conclusion, we've looked at the needs of the forest sector. We've looked at the placement of FP innovations and some of the work that we are doing. We understand that digitalization minimizes labor intensity, and that is the way forward. So freight management data solutions must consider use cases in forest operations during solutions development, and collaboration between the industry, research, and technology developers is critical to serving the industry. Thank you very much for your attention, and I will hand it back over to Dan.
Thank you very much, Adime. And if you have any questions on what Adime presented, he presented a very specific use case, which is a forestry department. He does still have a lot of expertise in ELD management, so if you are welcome to ask those questions as well. But we'll move on to the next and our next presentation by Mitra. Mitra is a freight transportation consultant at S&P Global. She holds a PhD in civil engineering for the University of Memphis, Tennessee, and she's recognized for her work in developing an emission add-on to multimodal commodity flow data, which is now a component of the Transearch product. Mitra's research primarily revolves around supply chain and freight transportation externalities, with a special focus on equity measures for assessing freight-related externalities across diverse population groups. So now I'll pass it on to Mitra. That will be our last presentation, and then we will go ahead to Q&A. So Mitra, please go ahead and do this. Thank you.
Hi, everyone. Thank you, Dan, for the introduction. Can you see my screen?
We do see your screen, but we see the presenter mode. I think you have to switch the display settings at the top of your screen. Yeah.
Okay, let me. Yep. Okay. Give me a minute. Okay, can you see that now?
Yes, looks good. Thank you.
Okay. So thank you for joining today's webinar. As Dan introduced me, I'm Mitra Salehi, working as a consultant in S&P Global, known as the IHS Market. Today, I'm going to talk about U.S. modal freight flows, emission estimation, and forecast. I'm going to start with an introduction, talk about why we try to estimate emission, what is the goal, and then review some of the methodology, well-known methodology to estimate emission. Then I'm going to talk about the development for Transearch database and also Waybill. At the end, I'm going to show you two case studies. I'm going to show you the carbon emission for Rhode Island and Michigan state. And at the end, I'm going to answer your questions. So based on S&P Global statistics, we know that total freight tonnage is forecasted to increase by 43%, or in other words, it's gonna grow by from 20 billion to 29 billion from between 2019 to 2015. And we also know that from this amount of tonnage, about 65% of that are transported by trucks. So The increase of trucks on the roads caused too many issues. One of the most important one is the environmental impacts, the environmental challenges like emission. And we know that CO2 emission is one of the most important pollutants that cause global warming. And truck is not the only mode of transportation. We also have air, water, and rail that contribute to this amount of emissions. So we can conclude that freight transportation is one of the major sources of air pollution. So we need to do something. To do that, at first we need to find the hotspot of emission. We need to estimate emission to identify the area that need attention, at least for the future, and try to mitigate this emission by implementing some of the strategies like adding some, some regulation, policy, or this stuff. We reviewed so many papers and study, and we come up with 3 different categories for estimation of emission. They are mostly based on distance, weight distance, and fuel. And there are 2 well-known models that can be used to estimate emission. One of them is MOVES model that developed by EPA, and another one is GRIT model, which developed by Argonne National Lab. In the next few slides, I'm going to talk about MOVES and GRIT model and what are the limitations or the inputs that they need to estimate emission. So for the MOVES model gives you an opportunity to estimate emission for road and non-road emission. But for road emission, you have both inventory option and emission factor. You can get the emission factor as well as inventory. But for non-road emission, which is mostly about equipment, you can only get the inventory option. Or as an input, there are some default data that should be used. For example, for the temperature, you have to use some of the data that are for 2011. And we know that due to global warming, this data is not valid anymore. We should use some of the more recent data, which is costly. Also, for the VMT, they use some forecast data. But their forecast is actually based on using a growth factor. They use the current VMT and then multiply it by a growth factor. But the most important thing that it was not considered was the load. We know that load of truck is one of the most important factors that impact amount of the emission that they produce. For example, in the graph, you can see the loaded versus unloaded trucks produce different amount of CO2 emission and CO. And that's significant for the long trip and with different speed. So what we found out was the MOVES model doesn't adequately capture the weight of the commodity. So what we did was we just tried to fill this gap by considering the weight of the commodity as well as the distance, because we know both of them impacts the amount of pollution that each one of the movements creates. So for those of you who are not familiar with TransSearch is a unique planning tool that helps transportation providers or agency to analyze the current and future freight flow by origin, destination, commodity, and by transportation mode. So what we did was adding emission column, or we call it add-on. We add CO2 emission to this database by and how we estimate emission. We use a combination of weight and distance methodology and got some of the data from our group. For example, we need the specification of truck weight by axle because we wanted to consider the weight of truck. We got commodity weight, OD distance from TransSearch. We got fuel type and fuel share from our mobility outlook. And I just want to mention something here that is related to electrification. We know that in the next few 30 years, we're gonna electrify the fleet. And we are doing that for some of the states now. So we should consider the fuel type because that's something that was not considered in the previous studies. And also we have the idling time. For the idling time, we could get that from the literature, but there was another way that we could do that, and we did that for one of the states using the telematic data like geotag. We could use the origin destination idling time for each of the movement and apply it, use it actually in our estimation. To just compare what MOVES model and GRIS model did and what we just modified. I didn't mention anything about the GRIS model, but GRIS model is life cycle emission. So it needs too many inputs that are not accessible for us. We didn't have access to that, so we had to use some default data that was that we didn't consider as precise. We didn't consider as precise as MOVES model. For example, they need the replacement frequency of fluid or the battery weight, some of the specific characteristics of truck that we didn't have access to that, or I'm not sure how some of the studies consider. I think most of them use the default data, which was not valid, I think. In S&P Global, we estimate emission for 4 major modes, including air, rail, truck, and water. We consider the commodity weight. It means we differentiate loaded truck versus empty truck. We try to use most recent data in the MOVES model if we wanted to get the emission factor from that. For example, the default data was the POC 2011 or YS 2002. So for the one of the inputs that was distribution data, we could access to our database and use more recent data. We also had the forecast data using a complicated methodology, not just applying a growth factor. So that was another improvement for this methodology. We also consider an estimated emission for rail, air, water by link. So we had the emission by origin destination by different modes. And we also were able to estimate the carbon cost by different characteristics, by mode, location, and also commodity. The other hot topics that these days are considered is equity. The fairness of carbon distribution can also be estimated using this data. And also, we had this data at different geographic levels. So what we already have is as county level, what we have at TAS or zip code. We could also provide those databases. In the next 2 slides, I'm gonna show you data analytics tool that we developed it for Michigan and Rhode Island. As you can see here, we developed the emission profile, CO profile for Michigan, and you see different modes. You can see freight tonnage by different modes, and also you can see which transportation mode is mostly responsible for this amount of emission. And in this case, for 2021 was truckload. You can also see which commodity was transported more and was responsible for this emission, which was farm product in that case. So you can also change the origin destination and see the emission by different links. So you can create a custom query for yourself and see which equipment, which mode is, and also which trade type create how much emission. And this is for 3 major modes: truck, water, air. We also have We also estimated emission for rail, but it was using Waybill, but due to confidentiality, I couldn't share that with you. But we could use the same methodology and estimate emission for that mode. The other example is the Rhode Island. You can see Rhode Island in 2015, and it's just for truck mode. It's not. It doesn't include all of the modes. And you can see the inbound, outbound emission, which commodity. The same thing that we had for Michigan. You can see which mode was responsible for the high amount of emission. You can even find a hotspot which county this study was at county level, but we also can provide at tag level or even zip level. So this is, for example, it shows that which area needs more attention. What should we do? That it should happen in 2050, and we should think about that, how we can plan ahead to avoid such things. And the other thing that we are working on is estimating the tire wear emission. We know that by electrification we will reduce the CO2 emission, but that's just the CO2 emission. We also, by electrification, we cannot avoid the tire wear particles. So, and we know by due to weight of battery, we will have even higher tire wear particles in the future. So we are working on that to estimate that as well. I think I'm done, and thank you for your attention, and I think we have some time to answer the question.
Oh, thank you, everyone. Thank you for great presentations. We'll go ahead and get into Q&A. Starting off, one of the questions that usually comes up, I'm seeing it on the chat list right now, has to do with data availability. Okay, so Mitra, thanks for presentation. The questions that usually come up is people ask, where do I get the data? Or where do I get that? It's not, we all know it's not free, right? We know the data is not free. And so can we just in terms of how for each, I think Jamie, you are here representing GeoTab. What are some of the things that you do to provide a certain level of confidence to clients before they go ahead and acquire your data? Can you describe a bit from a data management perspective? What are some of the things that, if you can, so I'll let Jamie, I'll put GeoTab on the spot a bit. How do we know that the data that you are providing to clients is of good quality and meets their specifications?
Yeah, that's a fair question for sure, and one that we definitely get, fairly often. A lot of it is because, well, not only because GeoTab has been around for 20 plus years, but in a sense of the data and analytics side of the house, we just launched the GeoTab ITS line of business, just over 2 years ago now. So definitely kind of a question that we see a lot. I think a lot of it comes down to GeoTab at the end of the day is the source of the data that we're providing. With that said, we are providing it in an aggregated and an anonymized fashion, but we are the source of the data, so we're very confident in what we're delivering from kind of the tools that JP shared, from the accuracy of the data. Does that answer your question, Dan, or was there a second piece to that?
Yeah, I mean, there are things like, let's say where you have low sample sizes and things like, how do you go about addressing locations where you have pretty low sample sizes that doesn't allow integration and things like that? Yeah.
Yeah, I would say that's kind of where our data science has done a lot of work with expansion factors. So, in the majority of cases, obviously GeoTab is obviously a sample of the population. But with that expansion factor work that our team has done, and with the over 4 million connected vehicles to date that GeoTab has, obviously you're going to see a vary in kind of market penetration depending on your geography. But we've performed these expansion factors I'd be happy to kind of share some of the methodology that goes behind that. But in pretty much all cases, we've seen kind of a 95% plus confidence interval to kind of show how confident we are. And if anyone's interested, I can definitely share the methodology behind the expansion factor work.
Okay. All right. Thank you, Jimmy. The next question is for Adime with the FP Innovations. So what has been some of the benefits you've seen, right, through using more and more data for, let's say, the forestry department? What have you seen in terms of what value are you able to quantify the value of strong data management best practices in your industry, and how those benefits are being measured and being then sold as a value add to clients and to those who are into the data collection space? Are you able to describe a bit from that?
Yeah, so I'll just speak very briefly. One of the areas that we've worked pretty hard on is working with our members and their partnering fleets to ensure that we are actually collecting quality data. So data quality has to do with collaborative work. So the data collection platform is there, the data acquisition platform is there, but is it working well? Are the inputs also accurate and correct? And these are all areas that need to be addressed to ensure that the data that is being collected is of good quality. So we work very closely to make sure that the data makes sense as a first step. Once the data makes sense and we are confident in the data that's coming through, then we can actually do some analysis and begin to show historical trends as well as future projections. So, for example, when we look at the dynamic cost rate rather than a flat tracking rate calculation, we are able to see whether the forestry companies that have to go through a negotiation process with their contracting fleets are providing or are using a cost rate model or tracking rate model that actually makes sense, and that ensures financial health of their primary tracking fleets. And so this negotiation is helped and supported based on the data that we're able to look at and the calculations we're able to do using real data rather than assumptions. So that's an impact area.
Oh, that's great. A follow-up question to that will be, how do you address the issue of data privacy with your clients? How have they been able to build confidence with them such that they know that you are not sharing data more? Because that's the biggest issue that we have with the freight industry, is that data is being, that the need for confidentiality because of how competitive the markets can be. How can you share a bit of how you guys address privacy?
Yes. So one of the ways that FP Innovations is positioned in the industry is what gives us an advantage when it comes to data and data sharing, right? So it's a collaborative research project or research program where different members contribute to our development of solutions and approaches. And so they do understand that the data that's being collected is going to be used to benefit each forestry company and their fleets, as well as other organizations that may be a competitor or not. And so this understanding of collaborative research is what allows them to entrust us with their data. They own the data, and so we sign non-disclosure agreements and data privacy agreements, etc., that help us to use the data, maybe even bring in third parties to help us with the development of data solutions.
Thank you with that. Okay, and then Mitra, one of the questions for you regarding the emissions estimation. So from your experience, where do you all see this going in terms of the future of emissions? And then from a data perspective, is there a need for emissions-based modeling to incorporate it into any commodity flow that we are doing or anything like that, so that, for example, if I go online right now to buy a plane ticket, it will tell me my carbon footprint, right? Is that where the industry is going in terms of making more informed decisions with emissions-based modeling for commodity flow movements, and what are some of the opportunities, especially for data users, to start thinking about this in the future? Yeah.
Something that is recently got more attention is the emission, CO2 emission, and most of the studies will consider emission from passenger cars and that side of transportation, not freight movement. So what we see in the future, I think it's going to be more interest in freight movement. As you mentioned, a good example was the ticket. When you get that, you see that you spend, I don't know, maybe 30% or something on the CO2 emission. So we definitely, I think we will have something like that, and there might be some regulation in the future. You can see in California, I don't know if anyone from California is here, but they have so many regulations regarding the emission, and I know that they are working even on tire pollution. So CO2 emission or other particular emission will get more attention in the future, because we're gonna go to get the zero emission goal, and that's something we need to do besides electrification. We need to find the hotspot of freight movement. We need to find which area should get more attention, and what strategy, mitigation strategy should we use. Some of them are not even available or applicable for some of the modes. Switching modes, is that good or not? We cannot switch the modes for some of the areas, or it's not economical for us to do that. So that's something that I know about. Yeah.
Okay. And that's great. Great response, Mitra. A follow-up question for you will then be: you spoke about mode switching, in the sense that for data, from a data perspective, right? We know the rail, pipeline, all of those. Where do you see the state of freight data when it comes to other modes of transport outside of tracking, which we know with ELD we've gotten to almost the highest level of granularity based on the past years? Where do you see that level of granularity, or where the future stakes for other things like pipeline movement, cargo move? Are we there yet, or are there more opportunities for in the industry to get more and better data in the future, especially in the rail? Yeah.
For the rail industry, we use available data to estimate the emission. We also have some of the information for rail movement in Transearch, but I think in the future, by considering some of the other factors that impacting the amount of emission, we definitely have more precise data on emission side. For other modes, not just rail, we also have some mitigation strategy like cold ironing. Some of the ports have cold ironing facilities. So if we estimate emission for example, for water, we can see which ports should apply. For example, if this port needs more attention, so this port produce this amount of pollution. So what is the greatest strategy to reduce this emission? This is the forecast for the emission. So we should not just focus on truck. I know that truck is the primary mode of transportation. Even in the future, we have statistics show 65% of the amount of total tonnage that I mentioned in my presentation are transported by trucks, but we should not ignore other modes of transportation. Rail produce less emission than trucks. That's why we try to in some cases, switch the modes from truck to rail. And in the future, with some technology that's coming, we can reduce the amount of emission in that mode too.
Okay.
But we should consider air and also water.
Okay. So I guess where we are seeing this is that in the future, freight modes or commodity flows will not just be based on cost in terms of the sale of freight, but then also the emission impact that so that's something we should be looking at, right, from a data perspective, a freight data management perspective. We should start incorporating into our infrastructure. Am I correct? Okay, that's great. All right, thank you. So I think unless there are any questions in the chat, I want to say a great thank you to everyone who participated. Thank you, Jamie, and the team from Geotab. We had JP, and then Adime Bonzi from FP Innovations, and then Mitra from S&P Global Insights. So Kelly or Adam, unless there's any last words, we would like to. I think our time is almost up, and I want to say thank you to the team for their presentations.
Nothing from me. Dan, thank you everyone for participating. Adam, any departing words?
No, thank you everyone. That fantastic presentations. Thank you, Dan and the team, and thank you, Kelly, for coordinating this entire webinar series. The recording will be posted within the next few days on the NOCO website, and you can also sign up for our newsletter on the website to get that recording in your email inbox. Thank you again, everybody. Have a great day.
Thank you.